Hello again everyone, this is Mr. Hoy. In this video I'm going to be solving two separate equations. These equations have square roots inside, so when we're solving this, we want to start off both of these by trying to isolate the square root sign. On the problem here on the left, we already have a square root sign, a radical here that's isolated, so we don't need to do anything to start that question off. However, in this question, you're going to need to divide both sides by 7 before you do anything else. So we'll jump right to the next line. That's just going to be 3x plus 22 underneath the radical equals positive 4. I'll pick up on this one in just a moment. We'll do the question on the left. Just remember, when you start that question, you shouldn't do anything else, no squaring, nothing else, until you have that radical isolated completely. Now the question on the left. Once the radical is isolated, you can square both sides, because a square root and the process of squaring are opposite things. So we can get rid of that square root by squaring both sides. The next line here is going to be 5x plus 19, now free of that radical, equals 8 squared, that's 64. In order to solve the rest of the question the same way we would normally, go in here and subtract 19 from both sides. You'll get 5x equals 45, and then divide off 5. X is 9. When you get to the end of a question like this, you want to plug it back in to see if the answer actually works. I'll discuss extraneous roots in a later video, but basically you want to come down here and plug the 9 back into the question. So it's 5 times 9 plus 19, all under that radical, equals positive 8. That's 45 plus 19, again under that radical, equals positive 8. That's the square root of 64, equals 8, which it does, so this one works out. Now over here with this question, we'll finish this one out. Again, we already isolated the radical. Now we need to get rid of the radical on both sides by squaring both sides, just like we did up here in the last question. Squaring both sides gets the 3x plus 22 alone, and squaring the right side gives us positive 16. At that point, we want to subtract both sides by 22. Get 3x equals negative 6, and divide off the 3, giving us x equals negative 2. We want to do the same thing to verify that answer, just like we were in the last question. We want to plug that negative 2 back in to make sure it works. So we'll go back to the original question. That was 7 times the square root of 3x plus 22. We'll replace the x with a negative 2. And we'll leave everything else the same, equals 28. This is 7 times the square root of negative 6 plus 22 equals 28. That's 7 times the square root of 16 equals 28. That's 7 times 4 equals 28, which works out. 7 times 4 is 28, which means negative 2 is an answer that works for this problem.